Okay, we've talked about sines and cosines. Now we're going to talk about their graphs. Okay, so here's a unit circle and our special angles, right? This is pi sixths, pi fourths, pi thirds, and then, going around. All right, so let's look. Remember, the sine value of an angle, the sine of this theta of pi thirds, is the y value, right? The height of this intersection point from the x-axis. So let's do a little dotted line over here. That there we could plot it, right? And there we'd say pi sixth, right? Sine of pi sixth is that value there, which would be, that's 1/2, right? All right, there's pi fourths. The height, we'll bring it over here with that little orange or green dotted line, pi fourths. So this is sine of pi fourths, which is square root of 2/2. Here's pi thirds. Let's bring that over. Here's sine of pi thirds, which is square root of 3/2. And then here we are at pi halves. The y value is 1. So that we bring that over here, and that's 1. Right? And that is the biggest that sine ever gets, right? The y value never gets bigger than 1. And then what happens as we go over here? It starts going down again, and in fact, sort of in a symmetrical way, right? Here, this was square root of 3/2. This will also be square root of 3/2. It'll be the same value here at 2 pi thirds, right? And we could do the same going down. What's going to happen? This doesn't show what happens, but as our pi value, or as our theta, our angle, gets bigger than pi, our y value becomes negative, right? But also in a kind of symmetrical way, right? Here at, let's see, this would be 7 pi sixths, right? This value is going to be, if we use our reference angles, let's just review, that would be negative 1/2, right? So we are going to see something similar to this curve that's going to continue on, but in the negative direction, right? So this is where this curve is coming from. Take a minute, maybe pause this video and think for just a minute if this isn't clear to you yet, okay? Because this is kind of important to see how this graph, where this graph comes from, and how it relates to what we've been talking about on the unit circle. Here is a GIF, or GIF if you prefer, showing this. So we'll just look at this for a minute. So here we have this theta is rotating around the unit circle, okay? So let's just look first at the red line, the sine value, okay? That relates in a straightforward way to the y value of this point of intersection as that angle rotates around from 0 to 2 pi, right? All right, and the blue value, the blue line here, is showing the x value. So it starts at 1. There's a negative 1. It's getting smaller. Starts at 1. Goes to negative 1. We're looking at the x value here, right? As this line goes around the circle. So maybe you could watch this GIF for a little while and think, okay, so let's look at these graphs. This is our sine graph, and this is our cosine graph. Okay, they look pretty similar, right? They're just shifted a little bit. So I find this graphic very helpful in thinking, okay, how does this graph relate to what we've been talking about in the unit circle? All right, now let's go to static mode. All right, so here are reference angles, 0 to pi halves, right? And we could fill in the rest of these by using reference angles, right? Kind of like we talked about with the first slide. If we plot these on this axis, on this XY axis, this is what our graph is going to look like. Okay, it's going to go up to 1, back down to 0. Remember, for sine, we're thinking about the y value when theta becomes pi. Remember, that's all the way across. The y value is 0. And then, as it goes to the bottom half of the unit circle, the y value becomes negative. Right? So we go from 0 up to 1, back down to 0, then down to negative 1, and back up to 0. Okay? And then if we kept going, this is going to repeat forever, right? Cosine, whoops, where did that come? There we go. Graph of the cosine function, remember? So this is, remember, cosine is the x value. So when theta is 0, our cosine value is 1. We start at 1, right? So hopefully these values here from 0 to pi halves are starting to look familiar to you, right? And if we graph those at pi 6, we're at square root of 3 over 2, square root of 2 over 2, 1/2, back down to 0, right? And then for the left half of the circle, our x values become negative until at pi, our x value is negative 1. And then it comes back up. Here at 3 pi halves, we're at 0, and back up to 1 at 2 pi, right? And that's going to repeat over and over as our theta goes on forever, or in the negative direction. So this is our cosine graph. We start at 1, halfway through we're at negative 1, and back up to 1. Okay. All right, so these are periodic functions. Okay. So for sine, we start at 0, up to 1. At pi, we're here, down to negative 1, and at 2 pi, we're back. And that is our period, right? We go up and down and up, and that is like a stamp. We could imagine having a stamp of that that's just going to go on forever in both directions. Okay, so our standard sine graph has period 2 pi. And if we look at our cosine graph, same thing. We start at 1, down to negative 1, back up to 1. And we could just take a stamp and go on in either direction and repeat. That will repeat. They both have one period is 2 pi. Sine and cosine have period of 2 pi. All right, so here's 2 periods, right? Here, this is going from 0 to 2 pi. This is from 0 to negative 2 pi in both cases for sine and cosine. So this is our base function, sine and cosine. Okay, these are periodic functions. So let's make some observations. Their period is 2 pi for both of them. Yep. Their domain, at what values can we put in them? Any x value. They go on forever, right? The domain is all real numbers. How about the range? They both go from negative 1 to 1. They can't be bigger than that, right? How about even and odd? Okay, so we talked about this a few lessons ago. We said that sine was odd and cosine was even. Now let's look at the graphs and see if that makes sense. First of all, cosine, remember, even means it has symmetry about the y-axis. If we fold it across the y-axis, it matches up. Sure enough, we can see in the graph that that's what happens. And sine, we said, was odd, right? We could rotate it about the origin and it would match up. Yep. Or if we folded it twice, it would match up. And that's the case, right? So sine is odd and cosine is even.